webinar, and that was very, very, still people remember that one, and I'm sure that this series is going to be very, very important one. We expect that we have shared the links to different groups. We have requested young students and scientists also to join and to listen these two great speakers, Dr. Harminder Singh Sidhu and Dr. B S Rajput. So without, we have friends from our university, Dr. K.T. Jadhav, many others students will join. So without any further delay, let us start the program presentation. That's Syed Ismail. Before that, if we can request Professor Gajendra
Yes.
Singh to say a few words. Professor Singh, please.
Dr. Singh, you can speak. No, you speak only.
Good morning, everybody. I'm in California. Good evening also to all the people. So I'm
Namaskar, sir.
You speak, no problem.
I think I just want to welcome everybody. I can see her and especially Professor Oki Makoto is always. Everybody, I think go ahead. Start. I'm just.
Yes. Dr. Syed, we can invite Professor Singh is basically advising that let us go ahead.
Okay. Yeah. I would like to call on Dr. Viswanathan to introduce Sidhu in short. Please.
Dr. Viswanathan, please.
Thank you, Dr. Syed. It's my pleasure to introduce today's speaker, Dr. Harminder Singh Sidhu. Dr. Harminder Singh Sidhu has 33 years of research experience in the area of farm machinery related to conservation and regenerative agriculture and layering it with precision water and nutrient management, both national and international level. He served at Punjab Agriculture University, Ludhiana, Erie, Philippines, and the International Maize and Wheat Improvement Center, Texcoco, Mexico, in various capacities as professor, senior research manager, and principal scientist, respectively. Dr. Sidhu made significant contributions in capacity development on scale appropriate mechanization and conservation agriculture for a range of stakeholders in Africa and South Asia through international workshops and trainings. His pioneering research in developing conservation and regenerative agricultural machinery and technologies resulted in adoption of laser land leveler, happy seed and super straw management system for combine harvester at large scale. His good rapport with the leading agricultural machinery manufacturers in India added his contribution in farm mechanization. He has 150 publications at his credit in reputed journals with 4,760 citations, H index of 34 and I-10 index of 66. He is recipient of many national and international awards, and to mention a few, John Dillon Young Scientist Fellowship by Australian Centre for International Agricultural Research, ISAE Fellow and Jyoti Award from ISAE, GS Kush Team Award for Excellence in Transfer of Technology to the Farmers, Team Award by the Government of Punjab, National Societal Innovation Award by NRDC for the Super Straw Management System and Innovative Mechanized Solution for in situ recycling of rice residue in rice wheat system of India and many more. He is an active member in a number of professional societies like ISAE, Indian Society for Technical Education, member in various committees and panels. Currently, he is Principal Scientist, Department of Farm Machinery and Power Engineering, Punjab Agriculture University, Ludhiana. So today he has consented to deliver his talk on conservation agriculture and water saving for sustainability in our short notice of time and organizing this webinar.
Thank you.
Thank you.
Thank you, Dr. Viswanathan. Dr. Sidhu, the floor is yours.
Thank you, Syed. Let me upload share my PPT. Or
Yes.
thank you, Dr. Vishwa, for the good words. And good evening, good morning to all of you. Um, uh, my name is Harminder Singh Sidhu. I'm going to speak on conservation agriculture and water saving for sustainability. I'm by my training, I'm a farm missionary person, and since my inception with the university PAU, I'm working on the machinery related to conservation agriculture or regenerative agriculture. So, our thanks to AAA for giving me this opportunity to talk on this very important topic, that is conservation agriculture and water for the sustainability in the agriculture. So, if we talk about the common challenges, we all know the water is the number one challenge for us in agriculture field. Second could be soil health, and now people are talking about terminal heat, global warming, and in some cases we have all seen if there is a less rain, that is also a challenge. If there is excess rain, that is also a challenge. And windstorms are like near the harvest, there is like windstorms, but people always talk about climate smart agriculture practices, that we should do water smart practices. It should be energy smart and nutrient smart. Even the now it is carbon smart, and our technology should be weather smart, and it should be easily acceptable by putting it into the knowledge smart window. So we always say that conservation agriculture is good for good year, but it is very good for the bad years. If we see in Indian scenario that every fourth or fifth year is a bad year for the agriculture. So before moving ahead, so let us, I will talk briefly on conservation agriculture. So we all know that we have three principles in conservation agriculture: minimum or no disturbance to the soil. Soil should be covered properly with the residue, and there should be a crop rotation. And we can get enhanced productivity, three benefits: richer resources and climate adaptation. See, conservation agriculture, through these key principles, influences the soil physical, chemical, and biochemical process. In turn, modifies the water and nutrient dynamics in the soil. Very interestingly, I want to share here the crown root initiation of wheat in the CA plot is early than the conventional till plot, right? And we have seen for many years, that CRI stage in conservation agriculture plots comes between 15 to 18 days, whereas in the normal system, the conventional system, it comes between near the first irrigation, that is between the 25th to 30th day of the after sowing. So when we are talking about a different method, so we need a new set of recommendations if we want to go this way. That is why people sometimes also talk about that conservation agriculture or regenerative agriculture is knowledge intensive, which implies that we need a new set of machines and techniques to deploy this system in our region, right? So for me as a farm machinery person, the role of machinery manufacturer and enrolling the farmers into this new possibility is very, very important, because we need to develop. It's not like it's always seeing is believing, but we should not be a preacher of conservation agriculture. I think our institute should be practitioners of the conservation agriculture or regenerative agriculture. So during this presentation, we will also talk about like how the conservation agriculture helps in improving soil health and other benefits. If you like see the principle of soil health, also minimum disturbance, maximum cover, maximum biodiversity, maximum living roots. Basically, we want to enhance the capacity of the soil to function as a vital living ecosystem that sustains plant, animal, and nutrition. If you basically what we want to do is transitioning from a degraded to a healthy soils. Or we can, in this slide, which is again we are transitioning from degenerative to regenerative agriculture. If like we have options, if you see the blue up arrow, that means we require less energy in one system and we need more energy in another system, right? And in the conventional system, yeah, from the conventional, we can go to green and then sustainable to restorative and then regenerative. So basically, what we are doing, and we are transitioning from the regenerative to the degenerative to regenerative agriculture. So let me talk about our region, that is Indo-Gangetic Plain, which is the most intensive crop production system in that area. We are always targeting that our goal is more production. That means more crops. The higher cropping intensity leads to a shorter window, because currently we are almost touching 200% cropping intensity in the Indo-Gangetic Plain. That means the window between the two crops will be short, which leads to some other issues also. So when we are having limited time between the two crops, that means we need more machines. And it is also, we know that seed in time is very important. So as soon as, if we see Punjab, Haryana, and Western UP, if we seed in time, then another issue is that timely seeding leads to timely harvesting also. And then the issue of crop residue management, you have all know about this issue in the past. So conservation agriculture also opens a window or to explore the possibility of simultaneously harvesting and seeding. Even we can think of relay seeding. When the first crop is still in the ground, we can relay our next crop to catch up the time. So our aim is to grow more with less, that is less of energy, less of water, less of nutrient, and less of money for more people. So we want to grow more with less of all these things for the more people. So for how we can achieve all this, right? So this is a first step, which is it is a prerequisite for conservation agriculture mainly in the irrigated region in India, the precision laser land leveling. So this was the first machine introduced in the region, and I'm happy to share with you more than 100,000 machines are now operational in India, and now it is earlier it was only adopted by Punjab, Haryana, and Western UP. Now it is moving to other regions, Maharashtra, Gujarat, and etc. etc. And it is the first step or the first prerequisite for moving towards not only leveling our land, but it is also improving the water use efficiency, and we can easily save like 15 to 20% water if our fields are laser level. And now these machines are phone call away in Indo-Gangetic panel. You don't need to own a machine if you want to get the laser leveling done in your field. So this is a phone call away. And second could be in because most of the field in Punjab, Haryana, Western UP, and some other regions are now laser leveled, and we can try a possibility of direct seeded rice. Although there were some challenges because the uh, rice seed, you have to seed the rice at a very shallow depth. So and laser land leveling helped us a lot to achieve a good germination. And even the basmati belt in Punjab, they are very much using this direct seeded rice. And other challenge was controlling the weeds in this direct seeded rice. Now we have the molecules which can easily control the weed pressure on the crop. So I'm going to show you a video where a seeder, which is a direct seeder, can seed. And if you can see in the picture, in the front, there is a 200 liters drum. And this is a machine. This additional system costs only 10,000 rupees to the farmer. So now if there is a like optimum moisture in the ground, you can direct seed your rice and simultaneously apply a weedicide in a single pass. So this is you can see a multi-crop happy seeder which can seed wheat, mung bean, rice, and maize, etc. in a single pass. And on the back, you can see there is a boom which apply a weedicide simultaneously. So it is quite popular now in Punjab and the other regions. So you can see after 45 days, a beautiful crop of rice, which is a direct seeded rice. So when the next challenge is how to, when we are harvesting rice, then Dr. Viswa was talking about the super SMS, that is a super straw management system with the combine. So as we all know that in rest of the world, you cannot sell a combine without the spreader at the back. But unfortunately, in India, our combines were without this spreader. So we developed this machine, this attachment to the combine, which is a super straw management system. So whatsoever is coming from the chute of the combine is spreaded back to the width of the combine. So I will show you. So basically, we are trying to address the crop residue burning issue in the region. So here is another machine which is called Happy Seeder, which is costing only $200,000, which can directly, or I should say, this was the first machine in India which can directly seed the next crop in the presence of residue. So I will show you a 1-minute video where we are harvesting rice with the super SMS fitted combine. And when we harvest rice, there is a sufficient residual moisture in the ground, and you can harvest your first crop and seed your next crop at the same time. And we with this because we use the residual moistures to seed our crop, and we are saving almost 20% of water which is required for wheat crop. So this is how the conservation agriculture also contribute in water saving. So we all know if we cover the soil with the residue, then there will be less evaporation. An added advantage is the weed population is less. And when we are putting 7 to 10 ton rice residue, which is often which was like people were burning it, if we put 7 to 10 tons of rice residue back to the soil, we are adding 39 kg nitrogen and 6 kg 6 kg P and 140 kg K and 11 kg S back to the soil. And at the end of the harvest, either we are getting equal yield or more yield, but with a single pass operation. And this technology is used in Punjab in a big way. Not only Happy Seeder, now there is an other new machine which is called Smart Seeder, which can also directly seed wheat into the residue. So people are using, like, it's more than 100,000 acres, 10 lakh acres. I should not say, yeah, 10 lakh acre area under this technology, and it is increasing year-wise. So we always say that this is a technology with the multiple wins, right? Because it is a single pass. On 30th October, you are harvesting your rice. On the same day or the next day, you are seeding your next crop. And you can see on 11th November, the wheat crop is coming out. And on 19th January, the whole your field is full green. So it is not only improving the soil health, but it also it is saving water, one, because we are saving one irrigation, and on the other hand, we are covering it with the residue, so less evaporation. So it's a single pass technology, lower cost, and farmers will get higher profits and lower GHG emissions and less weeds. That means less chemical leads and reduced weather risk. This is very interesting, how conservation agriculture reduces the weather risk. I will share with you during my presentation. So we published about this technology in Science. What are about the Happy Seeder, how farmer can stop burning crop residue. And we always say from the machinery side that you can tell number of technologies to the farmer, but it is always good that whatsoever we are recommending, it should be feasible, that we have a very short window of harvesting rice and seeding between. We have only 3 weeks, literally. So we have to, in 3 weeks, we have to uh, we have to 3 million hectares of harvest rice in 3 weeks, and more than 3 million hectares of wheat we have to seed in the same 3 weeks. So feasibility is the one thing, and if it should be economical, whatsoever you're suggesting, it should be economical, and it should be sustainable. We should not do the things like baling and etc., so that we can stop burning, but at the same time we are creating a big problem for the soil health. So it should be we should not do like this, that solving one problem and creating another problem. And more importantly, I think scalable. It should be, your technology should be scalable. So this is like, sometime people ask us that conservation agriculture can we do conservation agriculture for years and years? So I'm inviting you for this trial. This is we started this trial in Karnal in CSSRI, where we are comparing conventional tillage in rice wheat system with the happy seed or wheat for since 2009, right? So you can see over the years, either it is giving more yield or equal yield. So that means what we said, it should be sustainable. It is already proven, because here the data is only up to 2021. The field is sorry, the trial is still continuing. This is the long-term trial using this thing. So in 2022, there was a heat wave in North India. Then Indian ICR published a report that they compared the conventional till field with the fields with the sown in the presence of residue using happy seeder or smart seeder. So it is in their report that 76% farmers reported that they gained more yield, and 95% said there were less weeds, and 58% said that lodging was also less, where they direct seeded wheat after rice. So this is another small machine, smart seeder. So it is basically a new upgradation on the happy seeder thing. It is also direct drilling, but at the same time it is doing a strip tillage in the front of where we are putting seed and fertilizer. So it is also direct seeder. You can see a beautiful field with the residue on the and the crop on the field. Now, what I was telling you, that CA is good for good year and it is very good for bad years, and how it can, how the conservation agriculture or regenerative agriculture is a weather smart. So this is a one field in Ludhiana, 72 rain in one day, and when we visited two fields on the right side. So this is a CA field that wheat is sown after maize, in the maize residue, direct seeded maize, direct seeded wheat. And this is a conventional till wheat, where we do the tillage, and then so when we are after the 72 rain, when we visited the field, you can see the lot of water even is standing after 24 hours. And in this field, you can easily walk through this field. All right. So what I was saying in the initial my slides, if there is a less rain or there is excess rain, it helps in both ways. So this is another field. The right side is a conventional till wheat, and on the right side, wheat with the CA. Now you can see another big rain, 24 mm rain in one day, and then you can see the field. Another field, this is a conventional till field in Ludhiana, where the conventional till wheat is full of water after 24 hours, and the opposite of that. So this is a wheat in the residue. So that is why we always say that conservation agriculture techniques are also weather smart. So people are using not only for seeding wheat, they are also using the same machine for seeding maize into the residue. Even people are using the same machine for seeding mung bean into the residue. Um, and now I briefly touched upon the relay seeding. So what we can see that conservation agriculture, when you are not tilling or direct seeding, then we can use it. We can opt for a relay seeding also. So when we give our last irrigation to the wheat, if it is a paired row wheat, then the last irrigation of wheat is used as a pre-seeding irrigation for the mung bean. And with the little modification in the tractor as well as in the seeder, we can do this. So this is called opportunity crop. We are seeding mung bean in the standing wheat, and we used the last irrigation of wheat as a pre-seeding irrigation for the mung bean. And if you see, when the wheat is about to harvest, our mung bean is already 20 days. So this is another, we call it as an opportunity crop between within this, and we can easily harvest this crop using, there are seeder, so you can harvest wheat, and your mung bean will be on the ground. And even we can use combine harvester to harvest the same fields with the mung bean is on the ground. If we see, so on this side we harvested with the reaper binder, and this side we harvested with the combine, and you can very easily get 0.8 to 1 ton of mung bean between rice and wheat, and also improves the soil health because you are adding mung bean in between the two cereals. So for conservation agriculture, we also noticed that do we need separate varieties for conservation agriculture? So we did some study. We developed this machine which is called CA plot planter in Ludhiana. So which can seed the wheat plots into the residue, and we compared best of the best material from the breeders, wheat breeders, with using this machine, and we can seed wheat plots to compare different genotypes in the which genotype is good for residue, which is not. So not only very interesting results out of this trial is that wheat genotypes are, some wheat genotypes are good in rice wheat system, some are good in maize wheat system, and some are performing very good in the presence of residue, and some are performing good in the conventional tillage. So out of this study, there is like PAU has recommended a new variety. This is the first conservation agriculture CA variety with the PBW 689 3 years back, and which is very early seeding, suitable for very early seeding. That means you harvest your rice and seed with your next crop. and the quick germination vigor is very high, bold seed, and like very better yield. So when we are adding residue back to the soil, we are not only improving soil health. Now farmer also understand that we are improving the carbon content in the. So this is another initiative, very good initiative by the government of India, that they have already like did the framework for voluntary carbon market in agriculture sector. So this will also a very welcome step by all the people who are practicing conservation agriculture in the region. So this is now a few slides. What we thought that conservation agriculture can we marry conservation agriculture with the precision of water and nutrient management? So using the subsurface strip. So the purpose was, we call it as a conservation agriculture plus. So we thought we are not disturbing the soil for years and years. So and if we put the drip tapes below the soil in the rice wheat or maize wheat system, we started with the maize wheat system and then we moved to rice wheat also. So there will be minimum of that was the hypothesis, surface evaporation. As an engineer or farm machinery person, for me, if the drip tape is below the soil, 20 centimeter to 25 centimeter below the soil, so I can very easily do the mechanical operations, right? Effective fertigation can be done because we are giving water as well as nutrient fertilizer in the root zone, and maybe less weed because we are not giving water to the top 5 centimeter of the soil. So the possibilities of automation that, like, even I will share with you, Dr. Syed Ismail helped me a lot in this. And then the job was like at what depth, at what lateral or drip spacing, what should be the discharge, etc., etc. So we developed a new machine for putting a subsurface drip. So it is simply divide the machine is operated by a 55 horsepower tractor, and it is putting two drip tapes in the ground. So this was on the left of my screen. This was the first trial which we started growing maize with the subsurface drip irrigation. It was like 11 treatment, 3 replication, 3 plots, and big trial. And we started in 2013. Yes, through 2013, and we saw that we can very easily grow maize as well as wheat using subsurface drip. And interestingly, we harvested like a mega yield out of this trial. That is, we harvested more than 15 tons of grains per hectare with only 29 centimeter of water. Yes, this does not include the rainwater, but what the water which we gave to the crop. And then when we were successful in the maize wheat system, then we moved to the rice wheat system. So this is a rice. In 2016, we started with the rice. 15th, I think. We are growing rice with the subsurface drip, and then after the rice, then again a wheat with the subsurface drip. So it's almost like harvesting more than 13 tons of grain with the 80 centimeter of water. So we published this work in the various journals where that was like that we can not only save water using conservation agriculture, we can work further save water, adding a subsurface drip irrigation system in the system. So we also trying to establish a precision nutrition platform in Ludhiana, where our dream was that our crop should tell the tubal that I need water. So it is a fully automated irrigation system in Ludhiana, where we try to bring the different puzzles together as a farm missionary person. And as far as irrigation is concerned, we learned by doing, and thanks to Dr. Saeed Ismail, he always helped us for his with his guidance, with his whatsoever issue we did, remote monitoring, wireless communication, etc., etc. But it was a very good experience. And not only the irrigation system, even the filtration unit was also automated, so that it should be fully automatic unit. So irrigation automation programs now all knows who works in water field, that now everything can come, all the data can come to your desktop. And even like now so many apps, you can see what is happening in which field, what is the moisture, or how much irrigation is done on your mobile. But here are what I feel there are some challenges still. I think we need a continuous monitoring in subsurface soil potential, and we need also a reliable wireless switching facility, right? So automation with the precise and remote monitoring, and we need a cost-effective moisture sensor. I'm struggling for the last many years to get a cost-effective or reliable moisture sensor. Even recently, I talked with Dr. Rakesh Sharda that can we use a evapotranspiration method to automate irrigation, etc. I think Dr. Rajput may be throw more light on this. And one of our PhD student from the Soil and Water Engineering Department of PAU also did a study that how the water is moving below the ground, and how the nutrients movement is happening below the ground. So still my dream is because one of the challenge in the north West India is because in most of the states where the electricity is free, including Punjab, people use automatic to start and stop their pump. So I think I'm very keen to work on this. That can we automate the existing flood irrigation system, so that we can do alternate wetting and drying using a fully automated system. As soon as the crop, the moisture content in the root zone is less or at the trigger point, our irrigation system should do the flood irrigation. Even Dr. Saeed Ismail was in Ludhiana on 12th of this March, and he promised me that we should work at least to save 10% of water. I think if we see in that line, Punjab, Haryana, that I think we have like a deficit of at least 20%. So whatsoever we are pumping out and what is there. So I think that can even um, in the subsurface irrigation, we till now we put the fertilizers like DAP with the at the time of seeding, but we gave only urea that too dissolved by dissolving in the water directly in the root zone. But I think we should also work on supplementing micronutrients. And I don't know like how still I feel that there is a like uh, that pre-emergent or post-emergent we decide if we can we do that with the water. But in the subsurface drip, this is also very important that we not only save water, but the weed population in the field reduces year by year, because we are not giving water to the top 5 centimeter of the soil layer. So the weed don't germinate, and the weed population becomes less. So this is my last slide. We always say it's not only now if we merge the conservation agriculture with the precision water and nutrient management, we call it as a CA plus. So the conservation agriculture is the agriculture of the future and future of the agriculture. Thank you very much.
Thank you, Dr. Sidhu. You are a waterman, not a farm missionary man. You're talking about water. I think the last part is very challenging because we have almost 40 to 65% of the agriculture in the Indo-Gangetic plains is by command area or by canal irrigation. Okay.
Yes.
And this was real challenging even for the farmers, how to control the canal irrigation. And you told already the flood irrigation, how to automate. We'll work on it. With that few, I think we'll call on the next speaker immediately. Then we'll discuss together because similar line. I think I would request Dr. Viswanathan to quickly introduce the Dr. B S Rajput. Dr. Viswanathan, any problem?
Sorry, I was muted.
Go ahead.
It's my pleasure to introduce the next speaker, Dr. B S Rajput, a well-known soil conservation engineer, soil and water conservation engineer, contributed to research and postgraduate education at Water Technology Center, IR in New Delhi for almost 40 years. He is a former project director and a scientist of national repute. He has published 10 books and more than 200 research articles. He has developed 7 computer software on different aspects of agricultural water management. He has received many honors and awards for research, including the prestigious ICAR Rafi Ahmed Kitwai Award, the highest award an agricultural scientist can get in India. Besides research, he has supervised more than 20 postgraduate researchers. He was also awarded with ICAR Bharat Ratna Dr. C. Subramaniam Outstanding Teacher Award. He has widely traveled and is an elected fellow of National Academy of Agricultural Sciences and 6 other national scientific societies in India. Currently, he is the president of Soil Conservation Society of India, New Delhi. So today he is with us to share his experiences through a presentation on smart irrigation systems. Thank you, sir.
Thank you, Dr. Viswanathan. Dr. B S Rajput, the floor is yours.
इसको अनशेयर कीजिए, अनशेयर प्लीज. Well,
Yes, sir.
good evening, everybody. My teacher, Professor Gajen Singh, Sayed Saab, President Relay, Dr. Indramani, and all senior persons and colleagues. It's a pleasure to talk among the specialists. And it is a risky business and challenging too. Speaking before Sayed Saab on water looks difficult, but since the duty is given to me, I'll try my best. As we say that we are talking of all digital agriculture, all different types of names, all different technologies, getting into every field. I have listened to the presentations given by different academy awardees this year. Starting from agronomy to engineering, everybody talks of all the cutting edge technologies, and how much do they use and how much do they understand is a big question. But for engineers, there should not be a question of understanding. For engineers, the question should be of concern. And we really feel concerned that, yes, this is the time the engineers must prove themselves and come up to the expectations of the nation to increase the production with less inputs and less energy, and of course, to increase the production for under any circumstances. Since I have lost my.
No, you go to presentation only. Don't look at this team screen, presentation screen. Yeah.
Yes, it can't be lost.
Yes.
Changing
This is inferior. Well, anyway, now if we look to the just overall picture of agriculture, Indian agriculture, and what challenges we are likely to face, I consider, and I have got from what the 4: decreasing water availability, degrading soil, and increasing pests and diseases, and intensifying climate change. And out of all this, I have put the water first, because this is the most critical input for anything. And we have to be really careful that we do not miss the water and pay the attention it requires. Because now if we just see, Dr. Sayed mentioned it very clearly that in particular in the Indo-Gangetic area, is a lot of canal work is available. And if you stand in just near to the Satluj Canal, you will feel there is no depth of water, and there's no scarcity of water in India. You look to any big canal like Large Ganga Canal and Yamuna Canal, they give an impression that we are having enough and adequate and more than adequate water available with us. But it is a mirage. It is just like standing before the sea and saying that there's a lot of water, why is not a drop to drink? So we'll have to see the efficiency part in canals. The government and everybody has been very concerned about it, right from the time of our previous Prime Minister, Dr. Manmohan Singh. He said war for water. And he gave the slogan that we have to increase the water use efficiency by 20%. But giving the slogan doesn't help unless the Indians get into it and the farmers start using those technologies. Currently, on an average, it is just 38% efficiency of our canal system that is working. And that is a really pathetic situation for us. Same is in case of Indo-Gangetic plains. And if we have to become smart, and if we are thinking of becoming smart, then the word we have to really understand clearly. Britishers consider smart as a neat, lovely looking person, well dressed. But if you go to US, their smart means intelligent and solution oriented. But for us, it is something different, and let us define it in our terms, in terms of how we want to really go about it. So we say specific, measurable, achievable, relevant, and time bound. And when to define the smart irrigation system, it enhances the performance and automates irrigation systems to adjust irrigation on actual soil and weather conditions, resulting in conserving water usage, what Dr. Sidhu has talked about just a few minutes ago. So it is nothing but that. Now see, if we think of increasing water use efficiency or improving management, we must have the measurement. And it's a philosopher, irrigation philosopher has said, if you can't measure anything, you can't manage it, you can't improve it. And luckily, unluckily, unfortunately, we have very basic rudimentary measurement techniques used in our canals. You can just look to the lower photographs. They give you, and you can just think of, imagine what our systems are and what these systems are. They are solar operated automatic control gates, and they are remotely operable, programmable. And if we want to really improve the canals, we need to have the level monitoring, flow monitoring, gate monitoring and automation, power supply management, backup power management, wireless communication, and PLC-based control system and SCADA-based central control systems. Now, you yourself can imagine how simple or how difficult this whole thing is going to be under the situation. The present situation, you can have some idea that in the name of measurement, we have such type of scales put on the culverts, drops in the whole canal network. Otherwise, there is no other measuring structure available. Whereas now we have hydro, flow tech water, ultrasonic open channel flow meters available. So it is simply a question, either we start getting those things and putting in our canals, or we develop our own systems. So it gives the challenge to us that how can we make devices that can measure the flow more accurately. Now, if it's a question of improving water use efficiency in surface irrigation systems, then the senior people may know the gated pipe was very common in US, and they are that even given to us for use in border strips irrigation. And Australia gave these siphons from canals directly to let the water flow in a uniform pattern by putting number of siphons. And lately, the wall, the third figure in the top that you are seeing is the surge wall. It is, to control the flow, and it is a solar operated device that you are seeing, a small mobile-like structure on the wall. This is a solar operated controller which controls the flow with time. At least time management is there, so you can control. And the check basin, this is the most inefficient system. And then surface flooding, there's another system. This is not exactly a sprinkler. This is not exactly a drip. It's a rainwater, they call it. These are the pipes with laser-driven holes, very close and random in different directions. And they give a feel as if it is raining. But the advantage is that the entire flow is under pipe. So you can really control it. And if the flow can be controlled, it can be measured, it can be automated, and all those things can be done. Now, coming to other things, other methods, if we start comparing methods, you're all familiar with these figures, so I'll not take more time. I'll just simply say that drip gives you the highest water use efficiency because drip ensures no loss practically in the water from source to the field. or rather the plant. And if we have to do that, and if we have to achieve high water use efficiency in canals, then the only way out is that we start thinking of connecting canals to drip irrigation system. I'm showing you here 5 models available in the country already. This is the top one, is direct pumping from a distributory, is the headwork, drip headwork, and then the rest of the distribution is through drip. The green figure that you are seeing is a photograph, Google picture near Sirsa, and the straight line that you are seeing is canal. It's a canal irrigated area, and this particular gentleman has constructed a tank here, and he takes all the water during his term because the Varabandi is in force, so the time is fixed for which he'll get the canal water. So instead of using it then, he'll just store it here and distribute it in his field through micro irrigation. The another alternative is that the canals are elevated. And these elevated canals are normally 1.5 meter water surface is higher than the ground. And the black box that you are seeing is the headworks for a drip that can distribute the water from taking from this canal directly to the fields. Now, this is the example from the Gujarat, because the land is very expensive and the farmers are not ready to spare the land for the water courses. So what they say, that they started putting the solar panels on the canal itself, which are beneficial for restricting water evaporation and also cooling keep the solar panels cool. The ultimate thing is here, this near Amritsar, Tilwara, that the canal is just here and all these solar panels are along the canal. This is a power source. They pump the water from here and then they store in the natural ponds available and the reservoirs created. And from there, they use through micro irrigation. Some places drip, some places sprinkler. And particularly in that Kandi area, which was not non-irrigable, which was not under the command of earlier. So it is a boon for the areas which are already identified as out of command. Now, drip is not only that water saving, labor saving and all that. It is the only solution for irrigating in dunes, deserts and hills. And doing all this, if the technology of drip irrigation, micro irrigation was not there, nothing of this sort, nothing aeroponic, nothing hydroponic, and no A-frame farming, no rooftop gardening, that will happen. So it is very important that we improve it and make it to the farmers, bring it to the farmers by whatever means it is possible. And if we want to make this system smart, it's already a lot of effort has been done world over. India is not far behind, and our development in micro irrigation is at par with other countries, starting from simple time control to simple moisture control to diviners, which automatically give you the current soil moisture status. Then the weather stations, they give the information, and then ultimately we have come to this situation of a NetaJet sort of thing, where you can have multiple ventures. And as Dr. Sidhu said, that along with the major nutrients, the micronutrients are also becoming important. This type of system can be really very helpful. And then it is programmable. Here we have a small computer, and you can program for the whole season that which particular venturi operates for how much time. So these things are already done. This development is already available. And in terms of software, this is my team's work at WTC. All these our publications. And these DSS, Decision Support Systems 2, they are available on web, and they are available free. One is for design of micro irrigation system, and one is for irrigation scheduling fertigation systems. So this is just contribution from that. Now this is the latest. You might have seen lawn garden in the lawns irrigation with pop-ups. It is not a regular pop-up. It has got so many jets coming out. The most important parameter it has is that it works on a different operational variable pressure and variable coverage. So to irrigate an irregularly shaped field, you have to just put on your app on a mobile the distances once, and then it will remember next time. It will just irrigate only those areas which you have identified. So this is a very good device that has come up. Now the new developments are already there. We have the linear move systems and all robotic. So you can use it for applying fertigation, you can use it applying water only, you can apply fertilizer or anything that can be. Now, latest, everybody is crazy about drones, but drones are, yes, I was just reading in the paper last day only, that they are as good and may prove as bad too, if not properly used. Particularly if we are using them for pesticides, and if proper precautions are not taken, the environmental hazards will be very significant. But here I am showing that how drone can be used for irrigation, and that too exact irrigation or actual irrigation. First, you make the map of the soil, and then based on that soil and the water, the fertilizer requirement, then this drone can be ordered or planned for that, and then the irrigation can be done accordingly. As you are seeing, this is possible to do like this. Now, why IoT in irrigation? There are hundreds of things I cannot discuss in a short time, but I'll just take one example to make you feel why do we need IoT. Now, let us say one case we want to apply fertilizer to any crop. So number one, we must know how much fertilizer is to be given, how much N, how much P, how much K, how much micronutrients, in how many number of doses. Okay, then we have number of fertilizers available with different concentrations. So just finding out the concentrations to match that requirement, that is first. Then question comes when you apply. Different plants are sensitive to the concentration of different chemicals. For example, urea cannot be given in concentrations more than 300 ppm. Similarly, other chemicals. So you have to find out how much time of application of a particular fertilizer or chemical along with water is to be given. Then question comes, different at what depth is your root zone, how much is the nutrient moving to that level. And then it comes to weather, temperature, and several other things. So the complexity of a simple operation of fertilizer application can be so much that you may need at least 10 sensors for 10 different things. And if all those sensors are to be used in simple calculation of fertigation schedule, then they must be some combiner and some integrating unit. And that's what the IoT is, that if all the gadgets are net enabled, they can be integrated into one and then can be used in the scheduler for fertigation, and we can prepare the fertigation schedules. Well, I think I have not much to say because I thought that it will be more for discussion. So I've selected only a few slides. And in conclusion, I would simply like to say that smart irrigation using AI and IoT holds immense potential for revolutionizing Indian agriculture by improving water use efficiency, reducing input costs, and enhancing crop productivity. While challenges such as high costs, energy availability, farmers' awareness exist, strategic government interventions, private sector participation, and technological advancements can accelerate the adoption of these systems. With that, I would like to thank you and close it here. and open for discussion. Thank you, sir.
Thank you very much, Dr. B S Rajput. It's very interesting. I learned a bit more in this. I always learn. That's one of the gift of you people. And now I put the floor to question and answer. I would first ask Dr. He is a teacher for many of us. Gajan Singh, your opinion? You want to start?
Just,
He is
can you hear me?
yes.
Yes, I
sir.
can hear you. Yes.
Okay. Well, both presentations are excellent. I think it's a wonderful start for the webinar series, this one. What I find is a very common idea about the water use efficiency in both Harminder and TVS Rajput. The idea of using the canal water for micro irrigation, I think that is the future. I like to take it that every farmer should have a tank on his farm because you get a canal water for a limited time. That time is fixed by rotation. And that tank will do two things. Whatever is leakage, it will add to the groundwater. Okay, that's a good thing we are looking forward to. Also, the silt will settle down there, so it will reduce your cleaning the water, making for drip irrigation. So it will reduce the filtration load also. So I would like to suggest that we should, I think, promote this combination, making a better use of canal water. Okay. Other thing I'm little bit concerned is that Dr. Rajput mentioned about irrigation using drones. I think we are concerned about the how much load you can take. And,
No, you can put a pipe.
I'm just
Actually,
raising as an issue that I'm sure you people will give me solution later. But I'm so happy. I think it's an excellent combination. We have the best speakers to start, and I wish all the best for the future. Thank you.
thank you, Dr. Singh. I think the drones with a pipe of water going from top to bottom. That is our friend in Indore. He's working on it. So drones can be used for irrigation. A water pump, a pump attached to the pipe. So drone flies with the pipe. Water is going through it. Now, next question. I think Narendra. I see Narendra has raised his hand.
Yes. Yes, actually, what Dr. Gajan Singh has told, I want to just continue in that. The canal irrigation system, we can go for pins, we are saying, pressurized irrigation network. And in some pilot projects in Gujarat and the Narmada command, it is already in action. So the water is stored in auxiliary ponds and then through drip irrigation or sprinkler, then the crops are irrigated. So it is combination of actually the canals and the pressurized irrigation networks. The pins are already in the action. That all will be on. I want to. Very good talk, Dr. Rajput.
Thank you, Dr. Gadia. Thank you.
Rajkumar, can you please unmute yourself and speak?
I also join the earlier comments, the very good presentation. But looking at the water management issues in the Indo-Gangetic plains, where we are seriously facing the decline in groundwater levels. Once we introduce micro irrigation system, Dr. Rajput also mentioned that it could lead to horizontal expansion of the commands. Once it leads to the horizontal expansion, that means from the system we would be losing more water through ET. Hope you agree that once we horizontally expand, evapotranspiration losses will increase. And in fact, high evapotranspiration losses are the main reason for decline in water table, not the inefficiency of the surface irrigation method, because ultimately whatever deep percolation they are going back to. Maybe there may be energy losses, But as far as so that could be a concern for future if we horizontally expand by introducing some technological interventions.
I
Yes,
think I would just like to mention a few things about that, Johar Saab. I visited Tilwada project with the World Bank team, and World Bank experts also expressed similar apprehension, particularly with the solar operated drip irrigation system. They were saying that if you provide solar, they would be pumping more water and they would be getting larger area. They would be expanding area. I told, it is not America where people have thousands of acres. It is just very limited fields and they don't have extra land to irrigate. It's a small field, everybody has got a small tubewell, a small area. They cannot think of adding that area. What I am saying, canal irrigation, particularly the major canal system works very well. It is only the tertiary system which is not yet complete. Even water courses have not been completed for different projects. So that area always remains deficit in water. So if we can store the water there and then give it through drip irrigation system or apply any of the techniques that I shown 5, then we can have additional area with the same quantity of water. I'm not talking of extra additional water. With the same quantity of water, and evaporation loss is not a concern because the flow is taking place within the pipe. There is no exposed water moving anywhere except the pond.
Thank you.
Sir,
yeah.
increase in horizontally expansion would lead surely for increased evapotranspiration. There's no doubt about that one. And there are classic examples, I think in Haryana also, for example, in Mahendragarh, when sprinkler irrigation system was introduced in those sand dunes. Earlier, farmer used to have only, let's say, 1 acre wheat with 1 tube well. And once the the sprinkler irrigation was introduced, they could irrigate 5 or 6 acres of, let's say, wheat. That means ET losses would increase and the seepage losses will decrease. Although that seepage is not a preferable because you are pumping from the groundwater, but the main question is that ET losses will increase. So
Dr. Johar, you are right. If it is a case of sprinkler, that's okay. But in drip, we never give as much water to expose it for evaporation. So drip, it will not happen. It will happen in sprinkler. That's right. That's right.
I agree. I agree with that.
Anyway, sir, this is a complex
I think
topic,
let's
so we
move
can
to the next one.
That's okay. Next, I think we switched. I think this is a discussion is always good about.
Yeah.
Agree to. Jaspreet Singh. Jaspreet Singh, please. You're on the.
Good evening to all. I was listening on to this. I'm an environmentalist. I've got 2 issues with the water. Since I've been working with water conservation from last decade and a half. So my first point is the seepage through canals. So a lot of people are protesting that why do you line canals? So I had given a solution to all these protesters and the Water Resources Secretary Punjab that since you have to have a certain seepage when the canals were unlined, you at regular intervals on the left and right with a certain dia calculated according to the seepage which would have occurred had it been an unlined canal. So you should put pipes and do the issue of 2 say chambers silting unsilting it into the for water harvesting on at successive intervals with different dias, and also the base of the canal. I'm not talking about the sides, the trapezoidal this thing drawing. The base should be lined with krancha, which is the standing bricks, which allows a certain amount of seepage unless until it gets silted and clay. This was my first point, which they have incorporated into the Faridkot Canal, where there was a Jal Jeevan Virodhi agitation going on. This was agreed to, and I also told them in the new Malwa Canal, unless until there is a area which is marshy, where the water table is very near to the canal bed, so you should try this and that portion you should use the plastic sheet which was to be used in the water carriage of Sirhan feeder.
Dr.
And
Jasjit Singh, I'm sorry, Gajendra Singh here. Maybe
sir,
you should be a speaker in future to
Yes.
give all
Good.
these details, okay? Huh?
thank
Ah,
you, sir. Thank you.
Because this short time will not justify all the explanations.
I'm just giving you insights. The second
yeah.
Yeah,
point which I want to
Okay.
make is,
Thank you.
I've
Thank you.
got another point.
I think the
Thank
idea is that we should ask the clarifications, questions to the
I'm asking
speaker.
clarification on
Okay?
that. I'm asking
Yeah.
clarification. There is one Mr. Avtar Singh is doing naturalization farming. So when people they talk of only providing moisture to the crop, not irrigating them. So when he talks, somebody said drip also provides. He says when you put the drip to the root zone of the plant, it takes the nutrients down. But when we apply, they are doing it on bed
Uh, I,
cultivation.
I, I,
Justice, again,
I,
we are getting
I,
into the same argument. I think,
I think you can present. I'm sorry to
yeah,
interrupt.
we will
You
ask
can
you to
present
make a
one.
presentation sometime.
Yes,
Okay?
Okay,
please.
Yeah.
okay.
I would like to call Rakesh
Yeah.
Sharda, please.
Thank you, Dr. Sayed. It's a very nice effort that you have started. And of course, it's always quite welcome to listen Dr. Rajput as well as Dr. Harminder Singh Sidhu ji. And of course, they made a very nice presentations. I just like to add to the answer to one question of Dr. Johar. Actually, the thing is, of course, it is the efficiency that matters. We are irrigating only with efficiency of 30%, and moreover, just 1 month back, the government announced that now the farmers can transplant paddy on 1st of June. And just think of it that if 1/3 of the area is transplanted on 1st of June and there is no rainfall, no supplemental rainfall, then what a havoc it's going to play on the groundwater levels, particularly in the Indo-Gangetic Plains. And of course, we have from the recent reports, from the reports from the recent years, we have seen that it is even altering the poles, the North Pole also. That was a study by NASA because of the deficit we are creating in the ground. And of course, technologies like micro irrigation or drip irrigation are certainly going to prove a technology which will save the water which is there many years ago and which has been there provided to us by the generations. That's what I wanted to say. Thank you.
Hello. Thank you.
Thank you, Asman.
Dr. Indramani.
Thank you. Actually, both the presentations were, wonderful, and both the speakers are well known. And Dr. Sidhu talked that to conservation, how we can save water, and and Dr. Rajput about the efficiency. In fact, this even in this area like Marathwala and others where water is not there, only palm pond is the source of water. We are basically working on and very successfully that this palm pond plus solar pump plus micro irrigation. This is the solution. Okay, and Dr. Rajput's statement that increase the total irrigated area by same amount of water. And Dr. Sidhu's that do something so less water is need to be applied. That is the message actually, and I'm really very happy. And many youngsters have also joined today. They will be benefited, and AAA will take this webinar to include more and more people, more and more students. Today, 46 people have joined. Let us see that this number should swell and large number of people should join, and more emphasis. I was talking with Dr. Syed that students should be encouraged. They will not get opportunity to listen these great speakers. So that tomorrow we will try to reach more and more of the students and young scientists so that they can get the benefit of this this webinar. Thank you very much, Dr. Sidhu and Dr. Rajput Sahab, for sparing time for the benefit of the ag engineers. Thank you very much.
There is one Ravi Pratap Singh. He has got a question. You can talk, please. Go ahead.
Yeah, thank you very much. It's always very fascinating to hear about new technologies coming in, which are contributing to irrigation water use efficiency. My question is more around the budget utilization or budget efficiencies, because even in Pradhan Mantri Sinchai Yojana, which is focusing on enhancing the irrigation water efficiency, the highest budget realization has been 87%, which was long back in 2016-17. So are we also looking, means we are all engineers and scientists, but are we looking at that component, that certain budget allocations are there, but how we are able to use it 100% so that we can work more on this whole issue?
Thank you. I have a small two-liners for this. I think this is the first initiative we made because I've been finding that, farm missionaries, soil scientists, and you have agronomists. We need all of the people to work on this together. So, like, for example, one of the problems when I see in Punjab is also the around 1 to 3 meters is a depletion of water in borewell, which is somewhere from 40 to 60% of the area is irrigated in the whole intervegeting belt. It's also a problem. So, like what today, what TBS told regarding the measurement techniques, really it's a very difficult because we still use pan evaporation. And I see in the websites pan evaporation. So we have to work on this IoT or whatever TBS told. This is the emphasis we are giving. And plus the even control of canal water. So I think it's a very good discussion we had. I would request one thing. All of you, please tell we can extend these sessions because we planned for about only April. We can extend because we want to have at least all the people talk together. So what I would request you sincerely is when the speakers regarding the topic they have spoken that day, we discuss. Any other ideas we are happy to take you. Even 10 minutes you want to talk, 15 minutes you want to present it, absolutely no problem. We can include, you give me how much time you want, because we want have healthy discussion with all of you. Now, with these few words, I think I would ask Dr. Gajan Singh, shall we close down? Dr. Indramani? Or anybody
Yes,
has
please.
any? Yes.
No,
So,
let us close it. Let us close it. Thank you
so
very
we'll
much.
see tomorrow. You see tomorrow excellent topics again. You are seeing on the screen. They're very good. And one person is, I think, like I told you already, Chandra Batsala is very, very strong in rice cultivation. And Ravi Pratap Singh going to talk about entrepreneurship. Okay. Okay. So I would call this meeting closed today. And tomorrow we meet again at 7:30 IST. Thank you very much.
Thank you. Thank you very much.
Thank you.
Thank you. Thank you, everybody.
Thank you, Ji. Thank you. Good
Thank you,
night.
sir.
Good morning. Sat Shri Akal.